All right. So we're going to talk about compound interest today. So here's the formula right here. So the A in the formula, what you need to remember, the A is the final amount. And the P is the initial amount. This is how much you start with. Okay, so the P is what you start with, and the A is your final amount or what you end up with. Okay? R is going to be the interest rate in decimal form. N is the number of times per year the interest is compounded. And so I listed some of the words over here for the word problems. So if it's yearly, it's once. If it's annually, it's once. Semi-annual or biannually would be twice. Quarterly would be 4. Monthly is 12. Weekly is 52. And daily is 365. And then T is the number of times in how many years. Okay? So let's look at number 1. And we're going to follow this formula when we do it. So the amount of $500 is deposited into an account that pays 9.5% compounded monthly. What is the balance in the account after 3 years? All right. So first of all, before we even start this, let me tell you how you can avoid being made fun of. If you put $500 in 3 years, you don't have $1 million, right? The 500 is not worth $1 million. So look at your answers and decide whether you have a reasonable answer or not. So without actually doing this, like if you put 500 in, like how much might you have in 3 years? Like what would be a good guess? 15,000, 3,000? I would say 600. Let's see. So if I put 500 in, and what's the rate? It's 9.5, but I want that as a decimal, so it's 0.095. How many times per year is it compounded? 12, and it's for 3 years. So let's plug this in here, and let's see what our balance is. A would equal 500 times 1 plus 0.095 divided by 12 raised to the 12 times 3. So, before you start, let me tell you, you're going to want to take what's inside the parentheses. You're going to raise it to the 12 times 3, which is 36, right? So I'm going to take all of this, and I'm going to raise it to this. Now, on our handy-dandy calculators that we're going to do, you're going to want to do 0.095 divided by 12 first. So take 0.095 divided by 12, add the 1. I'm going to raise it to what power? 36. And then I'm going to multiply that number times 500. So $664.13. I wish we would have 15,000 after 3 years, or even 6,000, but no. This is about true. All right. So number 2. Your collection of baseball cards cost you $150 in 1998. In 2004, the value of the collection had increased by approximately 7.5% each year. What is the value of the cards in 2004? So first of all, how much did it start? How much did the collection start? 150. Am I right? 0.075. So how often per year? Right, it says each year, and it's just once. So 1. And then how many years? 6, right? 1998 to 2004. So I'm going to take 150 times 1 plus I got 231.49. Did anybody get that? Yes? I got 231.49. So did you take 1.075 raised to the 6th power? Did anybody else get that? Maybe I might have it wrong. I got 231 still. Yeah, I'm going with 231 and you are wrong. Okay, pick up your handy dandy calculator. Please type the numbers with me. 1.075. 1 plus this. Oh, Lord, have mercy. Okay, so let's read the, how much would you deposit in an account that pays 6.5% interest compounded semi-annually to have a balance of $5,000 in 15 years? So what's different about this one? They give you the final balance, right? This is my A, so the 5,000, and I'm looking for the P. I don't know it. I don't know how much I have to put now. The R is 0.065. The number of times it's compounded per year is 2, and the time is 15. So I'm going to take 5,000 Okay, so to find the P, I'm going to get this number, but I'm going to have to take 5,000 divided by this number to get P, right? So on your calculator, we're going to get this number, but I'm going to store it so we can divide and get the right number. So if you want to know how to do that, everybody do this with me. So type this in first. So 0.065 divided by 2, add 1, and raise it to the 30. If you did that correct, you have like 2.6103. So on the left-hand set of numbers, all the way above the on button, do you see the one that says STO? That means store. If you push the STO button, it's going to tell you which letter do you want to store it in. I'm going to store it in A, so push enter. So now what I'm going to do is I'm going to take 5,000 and I'm going to divide it by the number I just put in the store. So take 5,000 divided by, and to get back to that number, you see above it, it says recall. Above the store button, it says RCL. So push the light blue button and push the recall, and it says which letter do you want to recall. If you push A, it divides for you. And you should have gotten $1,915.43. Okay, any questions? So if we put 1,900 in and we just leave it sitting for 15 years, we get 5,000 back. That's all right, huh? Okay. So the next one is depreciation. And depreciation, the only thing that changes instead of a plus, it's a minus. And that means the value is getting smaller. So here's what we're going to do. We're going to buy a car. And it says it's $12,500, but how much should we spend on a car? $12,500, that's like a used car. Let's have a good car. What do you want to buy? All right, how much are we going to spend on our truck? How much? Okay, so we're going to spend $42,000 on our truck. We're getting a nice truck. It better have a sunroof in it. All right. So I'm spending $42,000. The rate is 20%. It's per year, so that's 1. And the time is in 3 years. So I want to see how much my brand new truck is in 3 years. So I'm going to take 42,000. So that's 0.8 raised to the third power, which is 0.512. So I'm going to take 42,000 times 0.512. So my $42,000 truck after 3 years is now worth $21,000. Would anybody like to take a guess if you are breaking even at your truck at this moment? You're not even close. Because you took a $42,000 loan to get the truck and you have to pay interest on it. So you owe way more money than the truck is even worth at this point. That's how banks make their money.